Okay, this one. To test the belief that sons are taller than their fathers, a student randomly selects 13 fathers who have adult male children. She records the height of both father and son in inches and obtains the following data. Are sons taller than their fathers? We have matched pairs here. We have genetic dependence. Um, so the null hypothesis is that there is no difference versus if we subtract son height minus father height, I would expect greater than 0. If the son's height is greater than the father's height, then son's height minus father's height would be positive, greater than 0. Okay, let's get our data here. Well, let's answer this part first. True, true. That's going to give us that we obtained the pairs independently, but within the sample, we would have the two scores dependent on each other. And we already have this part. I don't think I need to choose E. And 13 is not all that large anyway. It's not greater than or equal to 30. Let's see. Okay. All right. So, null hypothesis with these matched pairs is always that there is no difference, that there is 0 difference. If we are doing the height of the father minus the height of the son, which is the reverse of what I was just saying out loud, then I expect negatives. I expect the population mean difference to be less than 0. Now I need this, besides to see what order things were in. Okay, so we had 13 in the pairs. More to type. That's fun, huh? Okay, 70.2, 70.9, 69.3, 70.7, 70.5, 68.1, 68.4, 69.2, 71.1, 67.6, 69.7, 73.3, and 73.4. Notice that just to the left of that here, we see that that was the 13th entry in list 1. I have to be very careful that I don't miss anything. The particular pairing, this son that's 75.1 inches tall, is matched with that father that was 70.2 inches tall. I can't go, if I leave something out, I might have to do something like use the insert button if I go back and fix things. That's why I need to be careful right from the beginning. 75.1, 74.4, 71.8, 72.6, 71.7, 68.7, 68.5, 68.6, 69.8, 65.7, 67.3, 69.8, and 68.3. In some of these pairs, the son is taller, others, the father's taller. It's hard to tell. All right. We wanted the differences of the fathers in list 1 minus the heights of the sons in list 2. And it's filled in all 13 of these. So to get my T statistic, that was D bar minus a claimed mean difference of 0. In other words, subtracting 0, no difference there. So our D bar, the mean of the sample differences from list 3, divided by parentheses around S over square root of N, or S sub D over square root of N. One thing I need to change here was that the sample size was 13. Coming up with to 2 decimal places, that's going to be 0.01. Identify the critical values. Well, let's see here. From the table, if we are using alpha equals 0.01 level of significance, then the column we're going to look in is 0.005 with 12, since the sample size is 13, 12 degrees of freedom, and the 0.005 column. 0.005 right here, 12 degrees of freedom. I'm seeing a 3.055 there. And because this is a two-tail test, and we were asking about our sons taller, but then the order of subtraction we were forced to use, we're actually asking, are the fathers shorter? Less than 0 is a negative. So the negative T alpha to 2 places would be, where were we? Where were we? So 0.005 and 12 degrees of freedom. We'd be putting in negative 3.06 if we're going to 2 places. Okay. Let's just press check answer twice and see what they're saying. Oh. Okay, a little bit tired here. I did not need to divide by 2. That's only if we had a two-tail test, or if we were talking about a confidence interval with the plus minus, that's two-sided. 12 degrees of freedom, look under the 0.01 as it was, not alpha over 2 with 0.005, but just alpha 0.001. That 2.681 would round to 2.68 when they go to 2 places, but because asking if sons are taller than their fathers is equivalent to asking are fathers shorter than their sons, we had this as our alternative hypothesis. If we have something less than 0, then we'd have something negative. That's our critical value. Okay, compare the t-value that we calculated back here, 0.01, to that critical t-value. Well, without relabeling this in the earlier drawing, that negative 2.68 is over here. Positive 2.68 would be over here, and our t-value of 0.01 would be in between. So we have not moved far enough to the left in this left tail test to say that we have something in the critical region. Our score is not unusual. It is not extreme. Therefore, we are looking at this. Because we are not in that critical region here. We are not in that critical region. Do not reject, because the test statistic is not in the critical region. There is not sufficient evidence to conclude that sons are taller than their fathers at the 0.01 level of significance. Same as saying there's not sufficient evidence to show that fathers are shorter than their sons. That's the order of subtraction we wound up doing. Okay.